I've been like scatterbrained, like
Yeah.
with everything going on. So it's like
We didn't do blood clotting on Monday, right? I was gonna go over blood clotting because that's super like.
Yeah.
confusing.
Yeah, because I can study on my own for the quiz Wednesday. It's fine.
Okay. I mean, afterwards, if we, if we have issues, we can
I
quiz
have
over.
class at 5:30, so
Okay.
I can be here if you have time.
Alright. So we've got to talk blood, right? It's weird talking to just one person.
Right.
But anyways, so when we're clotting the blood, what's the word? What's the word for clotting blood?
Anticoagulant.
Not anticoagulant. What would an anticoagulant do?
Within the blood, so
Exactly.
coagulant, right?
Coagulation is part of what happens, but I'm looking for a word. It's hemo something. It's called, I wonder what chalk I should use. I have so many options now. I'm gonna use this little thin chalk. There we go. I know, with all the huge pieces of chalk available to me. I don't know how to use that big one. I don't know. Actually, it's called hemostasis, which makes sense, right? Blood and then still.
Yeah, stay.
Yeah, exactly. Blood needs to stay in. So when you get a cut and you feel the pulsing sensation, right?
Mm-hmm.
What is that? That's the first step. First thing that happens in your body when you have an artery or when you have a vessel that's hurt. It's called vascular spasm. Yeah. Because you have muscles in your arterioles and your arteries, right?
Mm-hmm.
So this happens in little arteries, not the big ones. But why would you want it to spasm? What would that do?
Wouldn't it send like a signal to the cells to go to the cut so it can start healing?
It doesn't send a signal. It doesn't do that. It doesn't call anything. But so if you have muscles, if you have the muscle in the vessel, right?
Mm-hmm.
And it's relaxed, and if it's relaxed and it gets cut and the cut is this big, what's gonna happen to it when it contracts? When the muscle contracts? It's gonna get smaller.
Mm-hmm.
So what would that do? If you made the hole smaller? You'd lose less blood. Yeah, so it is sorry, I'm like overwhelmed by the amount of talk I have. So you're gonna lose less blood. Simply because if the hole is smaller,
Mm-hmm.
less blood gets out. So vascular spasm, and then the second step. This is when we form the initial plug. What is that called? What are the little pieces of cells that make up the plug?
I don't remember anything from this lecture. I'm sorry.
What are the little fragments of cells in the blood called? They're not whole cells themselves. They're little pieces. The platelets. So we make a platelet plug. And that's the second step. So first your nervous system contracts the muscles, and then these little platelets that are floating around your blood, are they sticky inside your blood? Like, would they stick to each other if you didn't have an injury? No, because you clot and you have the clot inside and you would die. Or you get hurt.
Right.
So you don't want that. So they're not sticky when they're floating through your blood, but when you cut through that first layer inside the because there's 3 layers,
right,
as there is always. When you cut through that first layer, you expose something. It's connective tissue, and they stick to that. And they stick to collagen. So they're floating along, and all of a sudden they encounter this injury, and they encounter collagen, and they stick to it. So now they're sticking to, like, if if you have a cut, your vessel is damaged, and you have a hole right here, all of a sudden the little platelets will start sticking to the sides, and then they'll start filling in the little gaps. So they'll stick to each other.
Okay.
So you've got, so they stick to collagen, and then there's like 3 steps, and 2 or 3 steps in here. So this is step 1. I'll call it A. And this is platelet adhesions, they're adhering, which makes sense. And then the second step is called platelet release. So the little platelets have little vesicles inside of them, right? So do you remember what the vesicles are called? Hello. Sorry. Yeah, you're good. I'll make sure I actually played the video.
Like the videos, right?
So I said I did.
I did.
You're in my lab class too, right? Oh, okay. I was gonna ask you how the quiz go. I feel like it's gonna be like super hard.
Matter of fact, I got an 8 out of 12.
Oh Lord.
I mean, it's mostly little math equations,
Oh my god.
like addition and subtraction.
So we're gonna memorize that.
The formulas?
Yeah, you gotta memorize the formulas.
Lord.
At least on the practical, you won't get them.
Still not comforting.
I don't know if he'll give them to you on the quizzes. My professor didn't. I mean, but he didn't really quiz us the same way Dr. Saget quizzes us. But, I mean,
That's not very helpful.
they're not that bad. It's literally
his
like
quizzes aren't
adding
bad.
and subtracting. You just gotta remember what you're adding and what you're subtracting.
Oh god, okay.
But it's okay. Don't worry. You literally have half a semester to memorize those 3 equations.
But we got like almost 2 more days to
memorize too.
Right. Pretty much.
Don't worry. Don't freak out.
Now I can't concentrate on blood.
Well, you don't have to worry about that right now.
Okay.
We can worry about blood. It's okay. It's okay. It won't. The next 40 minutes won't change anything. But Anne Marie, I got your name right, right?
Yes.
Yeah. All right. We're talking about blood clotting. Were you
Okay.
here for any? Were you here on Wednesday?
Yeah.
You were. Yeah. Okay. So
So
it's
it's
the
the
same.
same one, right?
It's the same one.
Oh, okay.
Yeah. We're talking about blood clotting. So we've got through the vascular spasm. We're forming platelet plug, and we're on platelet release. So do you remember what's inside the platelets that gets released during this step? The little vesicles.
So you have the platelet plug.
Mm-hmm. We got the platelet plug. They stuck to the collagen.
And then the alpha clotting one, the PDG, that one.
Yes, but what are those chemicals contained inside?
Then no.
Start with a G.
Grow? No. Hold on.
It's those little dots in some of the white blood cells that you see under the microscope. You know, some of them have the dots and some of them don't. What do you call the ones that
The
don't have
RH?
dots? Not the RH, no. When you see it under a microscope, some of them have little purple dots
G?
in them. What are those called?
G.
G. They're called granules.
Oh.
Yeah.
Oh my
So,
God.
so you've got these granules, and these granules are little vesicles or little sacs, and they contain stuff. So, what are the 2 types of granules that we have in the platelets?
Like a granulocyte, you mean like that?
Not agranulocytes, those are leukocytes. Those are white blood cells. We're talking about platelets.
Oh.
I was just using that example because they're the same name. We have alpha granules.
Yeah, and no.
Which ones? I think you said it.
I was gonna say the adhesion, but no,
Not the
that's for
adhesion.
college.
Yeah,
Dense?
dense, exactly.
Okay.
I don't know why they're called alpha, and I don't know why they're dense. I have no idea. discovered and decided to name them. So there you go. And they each contain different things, right? So the alpha granules have two main things inside of them. Do you remember what they are?
They have clotting, right?
Clotting factors, which are good for obvious reasons, right?
Did you
Well,
remember this in math? I don't remember any of this.
This is lecture.
Oh, that's why. Okay,
This is a process you're probably going to want to become familiar with because you will almost 100% be tested on something in here. So, yeah, I know. So we've got clotting factors, and there's this thing called abbreviated PDGF.
No, what does that stand for? Because I have the abbreviation, but I didn't write down what it exactly stands for.
It's platelet-derived growth factor.
What?
So, why would a platelet release
What
growth
does it say?
factor?
Platelet what?
Derived.
Oh.
So why would a platelet release growth factor? So this platelet has stuck to this wound.
So we can get more of them to
Yeah, so not more of the platelets,
Bigger ones.
not bigger ones. Growth factor is going to go into the damaged cell, and what's it cause the damaged cell to do?
it's gonna like push it out, right? The damaged cell.
It's going to grow, it's going to regenerate. It's going to help these damaged cells. It's like giving them, it's like throwing cold medicine at them. So it's kind of like you get sick, right? You get sick and you're like, oh my gosh, I'm getting sick. So I'm gonna take some over-the-counter cold medicine real quick, and then I'm gonna go to the doctor because I really don't feel good. So this is the over-the-counter cold medicine. It's the quick fix just to get it started, get the process started, because you want to heal this wound as fast as you can. You don't have time to wait. You're losing blood. So regardless of if it's one blood cell at a time or if it's you're hemorrhaging, you gotta get this fixed quick. So you're going to release some growth factor, and then in the dense, we have a bunch of stuff in the dense granules. You have
It's ATP,
TP,
ADP,
ADP,
serotonin,
serotonin. That one's an important one.
and FSF.
What does FSF stand for?
Is it follicles? No.
No. It's the same abbreviation for follicle stimulating. Well, not really. FSF. Never mind, I confused you. Don't listen to me. FSF stands for fibrin stabilizing factor. It made sense in my head what I was trying to say, but then I realized as I was speaking that I couldn't articulate it, which happens quite a bit. So we've got fibrin stabilizing factor, and we're going to come back to that. That's going to end up at the very end of step 3. So we got fibrin stabilizing factor. We have 2 more things that are in here that are important.
Enzymes?
Enzymes. What do those enzymes stimulate?
Thromboxane.
Yeah, thromboxane A2. And I'm just going to write TA2 because I don't want to write thromboxane. So enzymes that stimulate, that make thromboxane A2. There's also one more thing that's super important. And it's what's stored in your bones.
You mean bone marrow?
No, not bone marrow. What's the ion? It's calcium.
Oh.
Yeah. So we need lots of calcium because calcium is actually super important for the next step, which is the confusing step. Calcium is super important because you can't clot the blood. There's a ton of steps where you need calcium in order to activate the next thing. And if you don't have calcium, you can't activate it, which means you can't clot your blood. So drink milk. Yeah, so we've got all this stuff, and this is all great, but there's the serotonin and the thromboxane A2 actually they share a function.
What does?
The serotonin and the thromboxane A2, they both
It vasoconstricts?
vasoconstriction, exactly. So these two are vasoconstricting. And remember, we were already vasoconstricting over here, but this was your nervous system contracting the muscles, right? And now we're releasing hormones so that the endocrine system can take over. Because the endocrine system makes everything last longer, and your nervous system, you don't want to have your nerves stimulating the muscles all the time because you don't need to. You have hormones to make it last longer, stronger effect. So we release hormones. So vasoconstriction. Sweet. And then we've got to call more platelets, right? Because these little platelets, this first round of platelets that has found this injury site, they bind to the collagen, and then they like extend little fake feet and they grab onto each other. What are little fake feet called? Little extensions that cells make.
Is it stratified?
Not stratified. No. They're called pseudopods. Yeah, and they're little fake feet. Some cells actually use them to walk along surfaces. So like they'll make this little pseudopod. They'll like grab onto something, then they'll like pull it in. They'll make another little foot, and they'll like pull in, and they can like walk. So they're little fake feet. Yeah. So they make little pseudopods. These platelets grab onto each other, and they're like, all right, we're gonna do this together. 1, 2, 3, and then they all release their granules. And then all this stuff gets released, and then the serotonin and the thromboxane A2 cause the vessel to stay constricted, right? And they constrict even more. And then the thromboxane A2 and the ADP actually call more platelets. So platelets swimming above them will see that thromboxane A2 and the ADP, and it's like a little red flag that says, hey, we need help. So those little platelets swimming up there are like, oh my gosh, we need help. I'm gonna go join. So now you have more platelets sticking, which is what you need because you want to build up that platelet plug. You want to make it as dense as possible. So that's cool. But are platelets alone going to be strong enough and a good enough fix? No. You don't just like, if you have a hole in the wall, you don't just like stuff some cotton balls in there and say that's going to fix it, right? You gotta put something else in there. So now we have to find some mesh to put in the hole so that we can cover with spackle later. So this is step 3, and it's called platelet aggregation. And this is where the coagulation happens.
Huh?
We should answer this on Monday.
I feel like we did.
If so, that's why I'm completely lost.
Oh, did you miss Monday? Ah, okay. Well, then there you go. This is the simplified version of what happened on Monday.
I can tell you what, were you in lab last week on Wednesday?
Yes.
Oh, because that day was like, I was so lost that day in lab.
He was going over a respiratory, like 300 miles per hour.
So,
Yeah.
maybe on Wednesday for SI, are you able to go over like respiratory for us?
Yeah, we could.
Check out that quiz.
Mhm.
Okay.
Yeah, we could. Okay. So platelet aggregation. So we've plugged up this hole with a temporary plug, and now we need a semi-permanent structure. We need some mesh, right? We need some mesh so that we can put spackle on it later. So this mesh, do you remember what it's called? Starts with F.
It's not fiber.
It is fibrin.
Oh.
Yeah. So
Oh
this,
yeah, fibrinogen, and then it goes into.
exactly. So fibrin is long strands.
It was in a corner.
Mm-hmm. Yeah. So fibrin is like long strands, that will interlace with this platelet plug to make it stronger, form the mesh. So, but do you really want long strands of fibers floating through your blood? No, you don't want long strands because they'll clump up, they'll like get stuck places, it'll be bad. So you don't want long strands. So you can imagine that the fibrin is made like this, and it's all of these little guys, these little sections stuck together, right? And they all fit nicely together perfectly, and it's great. And you can think of them as like beads in a necklace. So one fibrin strand is a necklace, and then I'll do that. This is a fibrin, and then one little bead is called a fibrinogen. So this little guy is called a fibrinogen. So these little fibrinogens will naturally be attracted to each other and form this fibrin strand, which is cool if you're clotting the blood. But if you're not clotting the blood, if you don't have an injury, it's going to be an issue if all of these little fibrinogens come together and form fibrin strands randomly, right? You don't want that to happen. So you've got to keep it from forming, you've got to keep them from forming these strands. So what your body does is your body puts a cap on the fibrinogen, and it puts a cap on it, so now it can no longer fit in the other fibrinogens. So now you can't make a strand, which is great if you're not clotting the blood. But if you have an injury, you've got to find some way to get this cap off of the fibrin, right? So you need a knife. So we have a knife floating through our body, and it starts with a T.
T.
Starts with a T, T-H.
Oh, thrombin.
Thrombin. So there's a
thrombin. Right.
Yes, well, thrombin is the knife.
Oh, okay.
Yep, so thrombin is the knife. And then this thrombin, it's also floating around in your blood. And this little pointy tip, I mean, these are, of course, super anatomically correct drawings. This is exactly what it looks like, with the purple and all. So this little thrombin will take this little pointy tip, and it will pop off this cap. And the fibrinogen combine together and make fibrin, and that's great. But if you have a bunch of knives just floating around, popping off fibrinogen caps randomly, you're gonna have the same problem. Fibrin is gonna form randomly, you're gonna clot, it's gonna be weird, it's not gonna work. So you also want to put a cap on the thrombin. So now we've got a cap on the thrombin too, and this does the exact same thing. It prevents the thrombin from cutting off the fibrinogen. And the thrombin, when it has a cap on it, has a different name. And what did you say that name was?
Prothrombin.
Prothrombin. It's like pre-thrombin, but pro. So basically, what we're going to talk about next, the whole point of step 3, because step 3 is when you go back and study with the PowerPoints, you'll see a bunch of charts and like extrinsic pathway, intrinsic pathway, and it can be really confusing, but the entire point is to make fibrin. So that's what we're doing in step 3. So in order to make fibrin, you have to get the cap off of the prothrombin, right? So that it becomes thrombin, so that the thrombin can take the cap off the fibrinogen, so the fibrinogens can make fibrin. Does that make sense?
Yeah, it's just like the steps are backward.
Exactly, yeah. Yeah, so I mean we could even label it. This is 1, this is 2, this is 3, this is 4. And that's our end goal. So I'm gonna erase this if you guys are good with that. Alright. And there's some really great videos by Khan Academy. Khan Academy has 2 awesome videos about blood clotting. And-
Academy.
Khan Academy, yeah. And they're really great. If you'll notice, my drawings are just like theirs because it worked.
Yeah.
So yeah, Khan Academy is awesome. Their pathways are a little bit more intricate than ours because we don't have to know all the factors. Because there's these little things called clotting factors floating around your blood. That's what the platelets release do. And there's 13 of them. We don't have to know all 13, thank goodness. Which is awesome because there's a lot. We have to know a very simplified version, but their videos still really help. Okay, so we have two scenarios when we get injured. We can either have, oh, I don't like that sound. We can either have a gaping hole in our artery, right? Or our vessel, and blood is just pouring out into, this can be internal bleeding or it can be bleeding outside your skin. Basically, you've just punctured a hole in this vessel and blood's leaking out of the vessel. Or you can have a situation where the vessel, let me draw that bigger, where the vessel has been damaged internally in one spot. So the blood is not leaking out of the vessel, but there's still damage. So we'll make this wall thicker just for illustration. And then it's worn down in this spot right here. So blood is still flowing through. It's not leaking out, but you have this damaged spot still. In both cases, you need a clot. So you've got to clot the blood either way. This situation, do you remember what it's called? What this one is? This pathway?
Extrinsic?
Extrinsic, yeah. So when you have this kind of injury, the clotting process is called, there's two pathways you can have, and this is called the extrinsic pathway. Because this kind of wound will trigger different things than this kind of wound will. And this one is called what?
Intrinsic?
Intrinsic. And the names are basically based on where the blood is. If the blood is going outside of the vessel, it's extrinsic. If the blood is staying inside the vessel, it's intrinsic. So say we have an extrinsic wound and blood is coming out of the vessel, right? So the tissue in here is going to release something. Do you remember what it's going to release?
The prothrombinase?
Not prothrombinase, that is later.
Calcium?
Not calcium. It's a very, very complicated name called tissue factor.
Oh.
Yeah. So the little damaged cells are going to release this tissue factor. This tissue factor basically says, help me, please. So this tissue factor, so now this is where we're going to get our cascading effect. Everything from here on out is going to activate something else. And it's just going to be like dominoes falling. So our tissue factor activates something very important. It's an enzyme. And what was it? You just said it.
The prothrombinase?
Prothrombinase. And based on the name prothrombinase, what do you think that prothrombinase works on?
Like clotting, you mean? Or?
It works on something very specific in our one of our
Like the thrombin?
things. Not the thrombin, but the
Prothrombin.
prothrombin. So this is what's going to cut the cap off of the prothrombin. So this enzyme, I'm going to write it in here. It cuts off the cap, which is awesome. So basically, extrinsic, you release tissue factor, which stimulates prothrombinase. So we're going to take a pause right here. And it is worth mentioning that calcium is involved in pretty much every step. So here you need to add calcium. Basically, if you just remember that calcium is needed pretty much in this whole system. If he asks you what ion you would need for tissue factor to activate prothrombinase, it's calcium. Talking about blood clotting, it's calcium. So, okay, so we'll take a pause there because the intrinsic pathway is also going to make prothrombinase. So we're going to figure out how it makes prothrombinase now. So when you have an internal wound, you have your little platelets are going to get damaged in some way, right? So now you have damaged platelets, and that's not cool. So those little damaged platelets are going to, they're going to release a couple of things. So what was in,
It's gonna release the phospholipids.
it's going to release phospholipids, yeah, and why do you think it would release phospholipids?
To help with the clotting.
Not to help with the clotting. What is a cell membrane made of?
Plasma.
Not plasma, the bilayer. The actual membrane itself.
Lipids? No. Lipids?
What kind of lipids?
Phosphor.
Phospholipids. So this platelet is releasing, these platelets are releasing the building blocks needed to repair these damaged little cells in here. So it's kind of the same concept as releasing growth factor. It's just releasing phospholipids instead. Because it's, you know, it's like throwing, it's just kind of throwing building materials at it and saying, here, I'll give you a head start. Start building, right? So it releases phospholipids. It also releases the stuff, what we care about right now is the stuff that was, one of the things that was in the alpha granules. So it was something factors.
Clotting factor.
Clotting factors, yeah. And you could get super detailed into what clotting factors are actually released, but we don't care. We just call them clotting factors. So it releases clotting factors, which is obvious, and then it releases, what is the ion?
Calcium.
Calcium. So it releases calcium. So if you noticed, the platelets when they formed the plug, they released calcium, right, from the granules, and then here we see calcium needed in all these steps. So the little platelets store calcium so that this process goes quicker. Because if they didn't have calcium, what you need to do is the platelets would need to stick, and then you need to send a hormone to stimulate the osteoclasts in the bone to break down the bone, and then you'd need to circulate that calcium all through your body, and then it would need to start this process. By then, you've lost too much blood. That doesn't make sense. So it makes sense for the platelets just carry little bags of calcium with them to get this process going. So these clotting factors and this calcium are going to lead, again, to prothrombinase, which is really cool. So we have two ways to get prothrombinase. All right, so now that we're at prothrombinase, what did we say that prothrombinase does?
Cuts off the cap off the prothrombin.
Exactly, it cuts the cap off of the prothrombin. So now our little prothrombin is free to do what it does, and it's actually called it's called thrombin. Once the cap is gone. So now we have a fully functional thrombin. And what is the thrombin going to do?
Cut the cap off of the
Fibrinogen.
That one.
Yep, it's going to cut the cap off of the fibrinogen. Exactly. And now we're going to make, now these little fibrinogens are going to bind together to make what?
Fibrin stabilizing? No.
Fibrin.
No. Fibrin. Yep.
Oh.
So yay, we've made fibrin. Remember, fibrin is the lattice work. So now we have these long strands of fibrin that are going to interlace with all those platelets that we collected earlier, and it's going to make the plug a lot stronger. because we need the plug to be strong so that we can add the scab and we can, you know, reinforce it and heal it. So we've got little fibrins, yay! So that was a long time that it took to get fibrins, but this happens in like a split second,
Right.
and it's super cool. Not quite done though. Fibrin stabilizing factor. Remember the platelets released that earlier? They released that during the platelet release step. So fibrin stabilizing factor is actually, what is it going to, thrombin also stimulates it. What do you think it's gonna do? Fibrin stabilizing.
Combine?
Not combine. Well, when you say combine, what do you mean? Combine what? Because the little fibrinogens combine on their own. They don't need any help. So I have my fibrin kind of looks like this. They're a bunch of squiggly lines, right? And they all line up next to each other. So go ahead.
I was gonna say bind together, but that's like the same thing as I just said about combining. But
Yeah, it actually will. I mean, it kind of adds little struts in here, and all of a sudden now these are more like a mesh work instead of just little parallel lines sitting next to each other. Now they're like stable. They're connected. And so this is FSF, and it's actually also known as clotting factor 13. So that might be one that's good to know. Fibrin stabilizing factor is clotting factor 13. So we've got that, and that's good. So we've got fibrin, it's stable, that's awesome. But we only made a little bit of fibrin here. We just made a little bit. So we've got to make more fibrin. And this is where the feedback system comes in. So normally in the blood and the body, we have a negative feedback system. This is an exception. What kind of feedback system would we have here? Or do we have? If it's not negative,
positive.
it's positive. So what is the difference between a positive and negative feedback? So positive feedback, so remember, well, a negative feedback is like if you have low insulin in the blood, right? So you have low insulin, and then you stimulate the pancreas to make more insulin, and so the low insulin goes up, and it hits a threshold, and the body says, I don't need any more than this, and it stops insulin production. So it keeps itself, it's like a thermostat at home. Temperature drops too low, you bring it back up, temperature goes too high, you bring it back down. That's a negative feedback system. A positive feedback system is like during labor. So the baby is ready, and the body stimulates oxytocin to be made and to bind to the uterus, right? Well, every time you have a contraction, more oxytocin is stimulated, which stimulates another contraction, which stimulates more oxytocin. Only when that baby is gone does that stop. So it keeps building and building
So
and
it's not
building.
going up and down, up and down.
Exactly. It's not going up and down, it's going up and up and up and up. So that's the same thing that's going to happen here, which totally makes sense. We want as much clotting factor, we want as much clotting as possible in this wound, right? You don't want it to stop you don't want it to stop. You want it to keep going until the wound is healed, until it's sealed. Sorry, I'm breathing in chalk dust. So it's going to have a positive feedback system. So what's going to get this positive feedback system going is the thrombin. So once you've made thrombin, all of a sudden the thrombin is going to stimulate a bunch of other stuff, and it's going to just set this cascade off in like high gear. So the thrombin, do you remember what the thrombin stimulates? Do you have it written down? It stimulates two things.
The phospholipids.
The phospholipids, yep. So the thrombin causes more phospholipids to be made,
Which is prothrombinase?
and prothrombinase, yeah. So we're increasing the building blocks that we have available for the cell to regenerate, and we're also upping the prothrombinase production. So prothrombinase makes thrombin, which makes prothrombinase, which makes thrombin. makes prothrombinase, and it just goes and goes in this cycle. And you have one thrombin, then you make prothrombinase, now you have two thrombins. Those two thrombins stimulate prothrombinase, now you have four thrombins, and it's like exponential, just goes up super quickly. And then you have a bunch of phospholipids to help the cell heal. So it just keeps going, and then once you've gotten to the thrombin, so like if you have an extrinsic situation, right, where you start with the extrinsic pathway, you go through the tissue factor, prothrombinase, then thrombin. Once you get to thrombin actually stimulates both of these pathways to kick in. So it doesn't matter what kind of injury you have, once you get down to thrombin, both of them kick into high gear because they have different factors and different things. It's really confusing. But basically, once you've gotten down to the thrombin, the entire system kicks into full gear. It doesn't matter what kind of injury you have, doesn't matter where it is, everything, all the clotting factors in the world just come together and like, we will do the thing. So, yeah, are there any questions about this? No? Did it make sense?
A little bit.
A little bit, yeah. It's a little confusing, I know. But what I did is I actually watched those Khan Academy videos, like, refresh my memory, get a deeper understanding of it, and then I looked at his PowerPoints and I picked out in his PowerPoints the specific things that he wants you to know. And luckily it's not nearly as confusing as it could be. So I'd remember this. If you want to take a picture of this, which will probably be useful for you when you're studying. Because this is pretty much his PowerPoint in a visual form. But is there anything still super confusing about it?
No, I just have to go over it.
Okay, yeah. Yeah, it just takes some practice, but it's something that we should probably be pretty familiar with.
I've never taken another lecture. Oh shit.
Yeah, I